So this is our first question, a basic question of addition subtraction, right? So how we can do it in the shortest possible time? Let's see. If we see the question carefully, we'll find a pattern. What is the pattern? You make a group of two. You make a group of two. Yes. What you will find? The sum of each of this pair is what? 98 minus 87 is 11. The sum of this pair is as well 11. The sum of this pair is also 11. This one is also 11. So if we add 11 four times, what we will get? We will get 44. So this is our final answer. What we can learn from this question? Instead of straight away jumping into calculation, adding the positive numbers and clubbing the negative numbers, then finding the answer, you first look at the question carefully and see if there is any pattern. You can group few numbers and answer the question quickly. Yes. So let's jump to the next question. Before jumping to the next question, this is a follow-up question related to the first question itself. It is similar to the first question that we did right now. Answer for this follow-up question you will find in the description box. So this is a second question. Let's read it. In in the figure, how many squares of any size, this is important line, of any size, can be drawn along existing lines such that the number in a square or the sum of numbers inside each larger square is even. Okay. So what does it mean by saying of any size? See, we can see there are these small squares, but we can create bigger squares as well out of this picture. How? See, this is also one square. Yes, this is also one square. Correct. Similarly, if I choose the outermost lines, this is also a square. Correct. So that's why at the end, the question is saying that each larger square, the sum of numbers in each larger square. Larger squares means 2 by 2 square or 3 by 3 square. Larger square is even. Okay. So let's start with 1 by 1 squares. Okay. 1 by 1 square means the smallest squares, 1 by 1. Okay. Let's see what are 1 by 1 squares. These small squares are 1 by 1 squares. Okay. So how many of these small squares are even as it is asked in the question? These are small squares and how many numbers are even? 1, 2, 3 and 4. So there are 4 squares with even numbers. Yes. Now let's jump to the next type of square which is bigger than 1 by 1 square, that is 2 by 2 squares. Okay. Now what are these 2 by 2 squares? See, if I combine two small squares like this and I combine two more small squares like this, I will get a 2 by 2 square. Okay, I will get a 2 by 2 square. And what was the question asking? The sum of the numbers inside each larger square is even. So do you think the sum is even? The numbers inside the this pink square adds up to even number? See, we have two odd numbers. If we add them, we will get an even number. And there are two even numbers. So if we add all these numbers, see, I'll write it here. Odd plus odd gives us even number. Yes. Similarly, if we add any number of even numbers, 2 or 3, we will always get an even number. Yes. We always get an even number. So I'm using this concept to say that the sum of all these four numbers inside this pink square is even. Similarly, we can draw more 2 by 2 squares. The another square can be this one, in which we can have 2, 5, and 3, 6, right? So again, we have 2 and 6 as even numbers, 5 and 3 and odd numbers. Again, the sum will be even. No matter which 2 by 2 square I pick, I will always get 2 even and 2 odd numbers. See, in this also, this is also one of the, let me change the color so that you can understand properly. Let me draw the other 2 by 2 square in a different color. So this is one of the 2 by 2 square. See here as well, the numbers 4 and 8 are even, 5 and 7 are odd. They will add up to give us an even number. Let me draw one more 2 by 2 square. You will see that that square also adds up to even. The numbers inside that square adds up to even. See, this is okay. This color is similar. Let me choose a different color, green maybe. So see this one. Yes, this is also a 2 by 2 square. Two odd numbers and two even numbers. They will add up to give us an even number. So how many total squares are there? 2 by 2 squares in which the sum of numbers are even. There are total 4 squares. Squares in which the sum is even. Yes. So we got 4 squares from this 2 by 2 squares. Now the third type of square is 3 by 3 square. This is the largest square that we can have. So that means this is the largest square. This one, 3 by 3 square. This is the largest one. So in this, let's see whether the sum is odd or even. Okay, how many odd numbers are there? Let's see. 1, 2, 3, 4, and 5. Now, two odd numbers adds up to even. Okay, but we have 5. We have 5. Odd plus odd plus odd plus odd plus odd will give us an odd sum, not an even sum, because this will combine to give us even. This will combine to give us even, but even number plus even number plus this odd number left out will give us an odd sum. Okay, please remember this. So this is odd. What about even numbers inside this? Let's see. We have 1, 2, 3, 4. So if you add 4 even numbers, this is very basic. You will get an even number. If you add 4 even numbers, you will get an even number. Now, if we club this odd sum and this even sum, because we need to add up all the numbers, odd plus even, you will get what? Odd plus even gives you odd sum, not even sum. So that means from this 3 by 3 square, which is 1 square, there is 0 squares. There is 0 squares, which gives us sum as even, which gives us sum as even. Yes. So 0 squares. So question was, how many squares are there where the numbers are even or the sum is even? So we are getting these two cases only in which the sum is even or the squares are even. So how many total squares? The total squares will be 4 plus 4, which is 8 squares, which is 8 squares. So this will be our answer, 8 squares. I hope you understood this question. Let's see a follow-up question which is related to this question. So this is the follow-up question. You can try this question on your own and check your answer in the description box. Let's jump to the next question. So this is our third question, and this question is somewhat similar to first question. You remember in first question, we created groups of numbers to solve it easily. Yes. In this question as well, we will try to form groups to make our calculation easier. So which two groups we can make? Let's see. So we can make one group out of this and this because these numbers are getting multiplied by 6. So we can create a group out of them. Second group can be created out of this and this because in this both numbers are getting multiplied by 4. That's why this will be our second group. So let's write them in groups. After writing them in groups, let's see what we can do. Now we can take 6 common from both these numbers. Yes. And if we take 6 common, what we will get? We will get 61974 plus 45 inside the bracket. Similarly, we will take 4 common from these two numbers. If we take 4 common, what we will get? Plus 4, 1969 plus 50. Now we will simplify this using BODMAS. We will get 6 times 2019 plus 4 times 2019. Yes. Now going forward, we can take 2019 common out of these two numbers. Yes. So let's take 2019 common, and what we will be left with? We will be left with 6 plus 4. Correct? So that means we will get 2019 times 10. Yes. So what will be our final answer? Our final answer will be 20,190. This will be our final answer. Yes. So I hope you understood how to form groups and simplify the problem. We have a follow-up question for you. Let's see that. So this is a follow-up question. Answers for this you will find in the description box. Let's jump to the fourth question. So this is the fourth question. At the corner dinner, lunches have one set price and dinners have another set price. 5 lunches and 3 dinners cost $70. So let's write it down in the form of equation. 5 lunches and 3 dinners cost $70. Okay, so I'm taking cost of one lunch set as L and one dinner set as D. And 3 lunches and 5 dinners cost 74. Okay, 3 lunches and 5 dinners cost how much? $74. Yes. And what do we need to find out? We need to find the cost of one lunch. That L is the cost of one lunch. So what can I see is if I add up these two equations, I will get 8 lunch sets and 8 dinner sets. Yes. So let's add them up. We will get 8 lunch sets and 8 dinner sets. This is equals to 144. So 8 lunch sets and 8 dinner sets. Correct. So what will be the cost of one lunch set and one dinner set? Let's find that out. So this is the cost of 8 lunch and 8 dinner. So one lunch plus one dinner set will cost us 144 by 8, which is equals to 18. Which is equals to 18. Yes, this is the cost of one lunch and one dinner set. Now, how can we use this? Let's see. Now, first of all, we can write this equation, the first equation, in a different way. How? This can be written as 2 lunch set plus 3 lunch set. Yes, I broke this 5 lunch sets into two parts, 2 lunch plus 3 lunch plus 3 dinners. Yes, this is equals to 70. Correct. Now let's go further. 2 lunch set plus, now this 3 lunch plus 3 dinner can be written as 3 times the cost of 1 lunch plus 1 dinner set. 3 times the cost of 1 lunch plus 1 dinner set. This is equals to 70. Now we very well know the value of 1 lunch plus 1 dinner set, that is 18, that we have found out here. So we will solve it further and we will get 2 lunch plus 3 times 18 is equals to 70. Going further, we will get 2 lunch plus 54 is equals to 70. Going ahead, we will get 2 lunch is equals to 70 minus 54, which is 16, which is 16. Correct? That means one lunch set is equals to 16 by 2, which is 8. Okay. So what is the cost of one lunch set? One lunch set is equals to $8. Yes, we have found it here. The cost of one lunch set is $8. This is our final answer. I hope you understood this. Yes. So we have a follow-up question for you. Let's jump to that follow-up question. this follow-up question you have to try on your own, and you can check the answer in the description box. Let's jump to the last question of this video, that is the fifth question. So this question is from the topic cryptarium, or you can say crypto. Each letter represents its own digit. That means we can't repeat the digits for different letters. Though if the letter itself is repeating, we can repeat that digit for that particular letter. But same number will not be repeated for different letters. Yes. So how many letters do we have? We have 10 letters. So how many digits do we have to use here? We have 10 digits. These digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 digits that we are having. Yes. And what we need to do? We need to find the greatest value of this 4-digit number. Ouch. This is a 4-digit number. We need to find the greatest possible value for this 4-digit number. So let's see how we can solve this. Before that, let's write this question properly. This is S T U B plus E O E. Please don't mistake this O as 0. This is O U C H. Yes. Now to make this the largest possible number, please think what should be the value of O. The value of O should be 9, so that this is the largest possible number that we can have. So let's replace all the O's with 9. So we have to replace this O and this O with 9. 9 and 9. Now please think what should be the value of this S so that this becomes 9. The value of S should be 8. And from where we will get that extra one? That one we can get from carried forward. U must be a double digit number, correct? And that 1 we are getting as a carried forward from that U. Okay, so 1 plus 8 gives us 9. That means S should be 8. That means S should be 8. So let's write S as 8. Please do not mistake 1 as a digit that we have taken from here. This 1 is coming as a carried forward number from this U double digit number. Okay, so since we have used 8 and 9, we can't use 8 and 9 again. We will not cancel out 1. As I told you, 1 is a carried forward number. We are not taking 1 from here. Okay, so 1 plus 8 gives us 9. Now what should be the value of T and U? Let's see. Now to make this the largest possible number, largest possible 4-digit number, U should be 7. Let's try to replace U as 7 and check. Now what will happen if U is 7? If U is 7, P and T should be 8 and 8. 8 plus 8 gives us 16. 16 plus 1 carried forward because C can be a double digit number. 8 plus 8, 16 plus 1, 17 and 1 is carried forward to 8. Yes. But 8 is already used. We can't replace T with 8. 8 is already used. Yes. So definitely our assumption that it can be 7 is not correct. So after 7, what is the next largest possible value that we can give to U? That is 6. Yes. Now how we can get 6 here? Not exactly 6. We should be getting 16 because 1 is carried forward. So according to that assumption, T and T should be 8. 8 plus 8 gives us 16. But again, we are repeating the old mistake that 8 is already used. We can't use 8 again. Yes. So that means 6 is also not possible. Our assumption is not correct. So let's remove 6. Yes, because our assumption was not correct. What is the next largest possible value after 6? That is 5. Now this is not 5, this is 15 because 1 is carried forward. So how we can make U as 15? If T and T adds up to 14 and 1 is carried forward because of this C double digit number, then it is possible. That means T has to be 7 and 7. 7 and 7, 14. Yes, plus 1 from carried forward gives us 15. Now, many students can ask why it is not 2 and 2, because 2 plus 2, 4, 4 plus 1 gives us 5. Please understand, this is not 5, this is basically 15 because 1 is carried forward to this 8. So we need 15, not 5. That is why 7 and 7, not 2 and 2, 4 plus 1, 5. Okay. So let's replace all the u's with 5. Let's replace all the u's with 5, 5 and 5. Let's replace all the t's with 7. So this is 7 and 7, correct? Let's remove the values that we have used. We have used 7 and 5. Yes. Okay. So what will be the value of this C? 9 plus 5 gives us 14. That means C will be 4. C will be 4. Yes. 14. 1 carried forward to 7. Okay. So we have used 4 as well. Let's cancel out 4. Now to make this largest possible number, H should be 6 because 6 is the available number. So first of all, let's write down the left out numbers 0, 1, 2, 3 and 6. Out of all these numbers, the largest possible is 6. So let's try whether 6 is possible or not. If H is 6, is there any other combination which will add up and gives us 6? 0 plus 1, 0 plus 2. There is no combination of B and E which adds up to give us 6. Yes. So that means 6 is not possible here. Yes. So what is the largest possible number after 6 that we can use instead of H? That is 3. Let's try. So if I put H as 3, is it possible? Yes, it is possible. 2 plus 1 gives us 3. 2 plus 1 can give us 3. Correct? Now you can interchange 1 and 2. It doesn't matter that much. Let's erase these letters and write the proper numbers. So anyone can be 2 or anyone can be 1. It does not matter. The answer will still remain same. So this is the largest possible 4-digit number that we can get. So the value of ouch is 9543. This is our final answer. I hope you enjoyed the question. So there is a follow-up question for you that you can try at home. The follow-up question is this one. Yes, you can try this question at home. To verify your answer, you can check the description box. Let's meet in the next video. Till then, bye bye.